the mighty Mississippi River. It has been called the nation's highway, and its uses have been many and varied in the growth and prosperity of the United States. Unquestionably, it's a powerful force. Engineers at the St. Anthony Falls Hydraulic Laboratory of the University of Minnesota channeled those forces to prove the structural integrity, functionality, and practicality of AnchorWall's concrete segmental retaining wall system. A wall 30 feet long and 6 feet high was constructed according to the AnchorWall shoreline and channel wall manuals to demonstrate to the engineering community the soundness of this AnchorWall system. The wall was built using Anchor Vertica units. As is true with all AnchorWall systems products, this is a mortarless retaining wall which requires no pins. Anchor Vertica, in combination with Anchor Vertica Pro and Anchor Diamond, make up AnchorWall Systems' family of products for engineered walls. The Anchor Vertica weighs 86 pounds, is approximately 1 square face foot, and 11½ inches deep. After the base course has been properly installed, each new course is laid by staggering the vertical bond of the preceding units, allowing it to lock around one side of the anchor locator. The units are pulled forward as far as possible. The correct setback is the result of positioning the units properly with the patented anchor locator. The cores in each Vertica unit are filled with free draining aggregate as each course is completed. This same aggregate is used as drainage backfill and reaches approximately 1 foot behind the back of the wall. A filter fabric is positioned directly behind the drainage aggregate. The purpose of the fabric is to prevent the loss of soil through the drainage aggregate. A 4-inch perforated poly drain tile is placed directly behind the base course and embedded in the free draining aggregate. The purpose of the drain tile is to allow the water to escape freely to reduce water pressure behind the wall. During wall construction, 6 standpipes were installed in various locations. 3 standpipes were placed in the free draining aggregate and 3 were placed in the infill soil. The purpose of these instruments is to measure the level of saturation of the soil during the test procedure. This wall will be 9 courses high. As the wall grows, care is taken to sweep excess drainage aggregate off the units so that level installation is assured for each new course. Immediately behind the filter fabric and the 12 inches of free draining aggregate, the wall is backfilled with silty sand-type soil. After each course of block is backfilled, the soil is compacted with the use of a plate compactor. Depending upon the height and topography of the wall, a geosynthetic reinforcing material may be necessary. In accordance with the engineer's plans, this material is placed across the compacted soil and units, pulled taut, and staked in place. Another course of anchor wall units secures the geosynthetic reinforcement at the front of the wall. Then it is covered and compacted with another lift of free draining aggregate and soil. With the wall complete, it stands prepared to face the rigors of a 3-part test. The first test